Okay, so last couple of lectures we talked about how to define data abstractions, right? And so we sort of went through each of these four questions. Talk about specifications. This is where you write required clause, modified clause, next clause. Right, so that was the problem of how do you specify a data abstraction. Then there was this question of how do you use a data abstraction. Right, so when you have classes, you have to create new instances of those classes with objects. Then in the last lecture, we talked about testing. Right, so if I have a data abstraction and I want to test it, then I'm going to write classes that try to exercise it by creating objects, driving them into a certain test, and then checking if the object is in the right state. And the last one is implementation. And we implemented the integer set, which is what I have right now show. So remember, we work with the integer set. It's a list of, its internal representation is going to be a list. And so, but this integer set data type, right, this class, really represents a set of integers. And so we declared a bunch of methods for the integer set. You can see them through the outline view. So I have a constructor where I create a new set. I can insert an integer, remove an integer. You can check if it contains an integer. I can check its size. Right? And so last time we wrote all the code. We actually implemented the data abstraction. Right? And then once we implemented it, we had to think about, well, do we do it right? And so we wrote some test code. So we had some tests that would actually exercise it. Right? So we had, test insert, for example, is a test. Right? It's annotated with that test. So we insert something into the set, and then we check that it, contains one item, contains exactly the integer we inserted, and then the size is the right one. So that's kind of where we are right now. So today I'll go back and kind of talk briefly about visibility. So we talked about visibility before the end of class in the last lecture. Kind of go back over it. Then I'll talk more broadly about data types and also interfaces, which is a topic that's related to data abstraction, especially data types. But interfaces relate much more to the implementation. So what we'll do is actually pack much more on the integer set class, and then implement interfaces for it, and then extend them in some other ways. Okay, so visibility, kind of as a starter, remember visibility refers to this modifier at the front of like a class declaration or a field declaration or a method. So this public here indicates the visibility of this class or this field or this method. And publicly really means that anyone could use this field, could create instances of this class, could call methods on an object of this class, and so forth. So the only other visibility modifier that you're going to care about in this course is private. Right? So public and private, they're like extreme opposites. So public really means that everything's available, and private means that it's invisible. And invisible to, if you're talking about a field, it's invisible to anyone who's outside the class. So remember this list that we declared, we made it public. So that means someone could reference it outside of this class. So if you look at the integer set test, we created a test where we tested negative numbers. And at the very bottom, we actually modified a representation of a set by referencing list directly. Right? We said set.list, and we could do this because list is a field in the integer set, and it's public, so we could get access to it. But of course, this is bad. Why is this bad? Why don't we want people to reference our internal representation of our set? What are some problems that you might run into?
You lose modularity. If you want to change your implementation, then they have to change.
Yeah, modularity, right? It's this really important concept that by making it private, you're actually preventing other people from relying on it, from depending on it. And what this means is that you can extend or add new features to this class, or maybe change your internal representation without breaking anything. So if I made this private, this would actually be the better design choice for this class. And if I save it, then actually you'll find that I have a compilation error back exactly at the place where I referenced this list. So now, this list, if you look at the error, it says the field integer set that list is not visible. Right? So this is talking about that visibility. I made it private, so now I can't reference it. Can't actually do this operation. So I'll just comment it out. So this sort of requires me to not go directly to my internal representation, but to use the methods. And that's why we have methods in a way. Right? They tell us how we're allowed to modify the representation without caring about what the representation actually is. So that's visibility. So you could do this for fields. You could do this for methods too. Actually, so there's no private methods that we have here, but I had to go to Invader, or Space Invaders game to find the private method. So here's one. It's a completely different project now, right? This is Space Invaders. And in Space Invaders, on your invader, when you move the invader, you need to check if the invader is outside the boundary. Like outside of the bounds of the game, outside of that box. And the way you do this is by calling an internal helper method, as we would call it, handle boundary. And handle boundary is just a really simple function. It just checks that if your x is outside of the bounds, then it sets it to the bound. Right? If it's less than 0, set it to 0. If it's greater than the width of the game board, set it to the width of the game board. So this method is completely internal to the invader. It's not a method that you would want anyone to call, but it's a method that you would want to use internally within the class. And so it's made private and therefore invisible to anyone outside of the class. Right? So this is kind of an implementation detail of how you handle invaders that are outside of the border, right? Outside of the board game. So for example, if you wanted to crash the game or show a warning or something if the invader is outside of the border, then you would have to change this method, a helper, right? And you would do that without anyone else, depending on it. So private methods are a way of implementing extra functionality within the class and hiding it from anyone else. So that's kind of visibility. Do you guys have any questions about public or private visibility? Let's talk about types and interfaces. So it's actually a really good diagram that Gail drew in her previous class that I'll draw here as well. So what I could do is actually just write down all the objects that I have. All the things that I'm kind of dealing with, right, in Java. So I'll make a box for just, Java class. Java class, and I have some notion in a cloud of a data abstraction. And so we can relate a Java class to a data abstraction, and that my class represent this data abstraction. Right? When I'm creating a class, I'm using the class to stand for my data abstraction. Right? So that's like, this is in programming land, and the data abstraction is very much in my head. Then we have these other things called types. So a type something that a class defines. So really, every time you're creating a new class in your Java project, you are defining a new type, a new data type. And the new data type allows you to extend your language. So, I might have some primitives, like I might have an integer, I might have Boolean. So these are also data types. But if I just always write programs using these very primitive data types, I'm not going to get very far. So what classes allow us to do is to define new data types. Right? They're allowed us to extend the kinds of things we can reference in a language. So in an integer set is a new kind of type. It's a new kind of data type that allows us to say integer set, integer set equals new integer set. So once we do this, the set now becomes a first order object that we can reference in the program. It becomes a type. So integer set is a type. So then the relationship between the data abstraction and type are sort of fuzzy, right? They're really closely related because the data abstraction, in a sense, also represents a type. But this guy typically has some kind of specification. So when we use those comments to actually define what a method does, right, that was a specification. So we defined the effects, said what is necessary, or what the method requires, and they also defined what the method modifies. So all of these belong to the data abstraction. So these are types. So types in Java, you always see them when you declare variables. So in my integer set, my type of list is going to be this thing, linked list integer. For example, the type of I, which is an argument that you pass to insert, the type of I is integer. So this is an object, and this is the type of the object, right? Or the class that is used to define this object. And then Java classes, of course, are used to create objects. So you'll have an object in the diagram as well. And Java class creates these guys using constructors. So when you say new in your program, that creates a new object, right? And when you create the new object, you have to specify the type of that object, right? And so you're creating a new object that is an instance of a class. Any questions about this kind of diagram? Sort of through data types. I mean, we've seen them in the program throughout, right? We talked about lists, we talked about integers, strings, right? Those are all data types. And this is one unified way of thinking about these new objects. So the next thing we're going to talk about are interfaces. So interfaces are really funny. So the way to think about an interface is that it gets its own box. An interface also defines a type. So now you have two ways of defining types if you want to create new ones. So if you want to create a notion of a student in your program for course registration, you could define a class called student, or you could define an interface called student. And the difference is that the Java class represents the data abstraction. It also implements the data abstraction. The interface defines a type, but it doesn't implement anything. Right? So an interface only contains signatures of methods. And a method signature is essentially just the first line, the declaration of a method. So this is the method signature of the constructor. Method signature of the insert method would be just this thing that I'm highlighting. Public void insert integer I. So that's a signature that allows you to kind of refer to this method without talking about the implementation of this method. So what an interface talks about is just the set of methods that are relevant to your data type. It doesn't tell you how you're going to actually define it. So we haven't seen interfaces yet, but if you've been working on assignment 2, then there's an interface in that assignment, right? So there's this allocator service, which is an interface which hides the implementation from you. So we gave you an interface, and the implementation for that location service is on the server. So you don't get to see it, but you get to use it. Because all you need to use a data type is really a set of methods. Okay, so what we'll do now is actually play around with this notion of interface in the context of the integer set. So, so the background here is that if I have my test suite, I can run it. And if you run it, you'll notice that it runs really slowly. So it's going to execute, and the reason it's slow is because there's 100,000 items that it's actually dealing with. So it's now creating a list that's 100,000 lines long, items long, and testing the size, and then contains whether it contains the right objects, whether it contains the one object, so forth. So this thing is going to execute for a long time, bit by bit. So this kind of leads to the question of, what's slow in the system? Is it that my computer's slow? Is it that Java is slow? Is it that my implementation of the data type is slow? Right, so there's this question that you have to answer if you were to implement this thing and use it. So one thing we could do is actually declare an interface to represent my set of integers. So what I'll do is, here's how I'm going to do this. So first, I'm going to refactor and rename my integer set. So this integer set is a very specific implementation of an integer set, right? It's a list implementation. So I'll call this list integer set. Maybe even more specific, linked list integer set. So when I'm renaming it, it's actually renaming the file name, it's renaming this line, and it's actually changing all the instances of integer set to linked list integer set. Right? So this refactoring operation is pretty advanced. It's actually looking through all the dependencies on that name. And now, I'm going to refactor and extract interface. So what this will do is actually create a new interface in my project. And so I have to give it a name. So I'll just call this the integer set. And then it's going to ask me what sort of methods do I want to be part of this interface. So I'll just select all of these. Press OK. And what will happen is I have a new Java file. And the file is called integer set. And it's an interface. And the way you know it's an interface is because at the very top it declares integer set as an interface. Visibility is public, so everyone can reference it. And if you look within the body of the interface, it contains just the method signatures, right? Just like I was saying, contains a way for you to talk about the kinds of things you could call on the interface, but it doesn't actually tell you how they're implemented. So no body. So in fact, it would be illegal to implement it. So if I attempt to implement it here, I'll get an error. I'll say something like, abstract methods do not specify a body. So it's considered an abstract method in the sense that it's supposed to refer a class of methods that have the signature. Right, so I'm not even allowed to implement it here because it's an interface. Okay, so that's great. And then in the linked list integer set, what you'll notice is that the class declaration has been changed to include this dependency on the integer set interface. So now when I'm declaring this class, it's a class that must implement my integer set interface. So what does that mean? What do you guys think it means? What does it mean to implement an interface? So my interface is just a collection of method signatures. So if I were to implement it, what am I doing?
Implement each method that's written in the interface.
Yeah. So that's the intuition, right? So when I'm implementing an interface, I'm actually giving you the implementation for all the methods that are listed in that interface. right? And because I did this refactoring automatically, I actually extracted the interface from the implementation. So this implementation already implements all of them. So for example, there is the insert method in my interface. And okay, I have an insert method in my implementation of the interface. Right, so I have implementations for all of these. But here's the critical thing. If I were to actually comment some of these out, like let's say I commented out size. I decided, you know, I don't want size. What you'll notice is that at the very top you'll get an error. And the error will tell you that actually you have to implement size. Right? So for me to implement this interface, if I say that, then I have to implement all of the methods within that interface. I can't leave something down. So I'll bring it back. You can press Command Control slash to comment that multiple lines. Okay, so I did this kind of refactoring, but why is this actually useful? So what I'll do now is actually implement a different kind of integer set. So let me take, we'll just create a new class. And I'll call this hash set integer set. And it's going to implement the interface integer fetch. I guess not. Let me just add this guy. So I have a class, hash set integer set, and it's going to implement integer set. Now it's an empty class. But because it implements the integer set, there's a bunch of things I have to do, right? Like I said before, you have to implement all of those things. So here, if you hover over it, you can say add unimplemented methods, and Eclipse will automatically actually give you all the things you have to implement. Right? So I have all these things, and it's kind of the same set of methods that I implemented for my linked list version. So what I'm going to do now is actually implement a version of integer set. Oh, and hold this here. That's awful. I'm going to rename it. I'm going to implement the version that is based on the hash set. So it's not going to use a list internally, it's going to use a set, which is built into Java. Okay, so it's going to be private hash set, which will contain integers. And this will be my internal representation. And to use this guy, I have to import it. So now hash set is part of my imports. So the first thing I have to do is instantiate it. Right, so I create a constructor, public hash set integer set. So I have my internal representation, and now I'm going to fill in all of these methods. So we know all of these really well. So if I want to insert integer I, my integer set has the specification for insert. So this is what I need to do when I want to write this insert method. And the effect must be that the integer I is added if it's not already in the set. So I'll say, okay, if my internal representation does not contain I, then I'll say internal representation that add I. Very similar. Remove, specification for remove, just says remove I from the integer set. And the requirement must be that it's already part of the integer set. So I can just go ahead and call remove on it. So remove I. So I just return terminal representation.contains. In fact, the whole thing is kind of easy. Because I'm calling through to my internal representation, which is this, which is a hash set. Oh, actually, I have to return it. Can't just compute it. Now I have this. Now I have two implementations of integer set. I have an interface, which defines a set of methods that you must have in an integer set. And then I have the hash set version, and I have the linked list version. Now the reason we did this is partly because I have this test suite, and the test suite uses integer set. And whenever I run this test suite, I actually have to use some specific version of integer set. So when I do run before, remember this code runs before every test, I'm actually going to instantiate a new linked list integer set. And this is the version that was slow. In order to use the second integer set that I just defined, I use the hash set integer set type here. Probably have to import it. And voila. So what I've done is actually replace one line of code in my entire test suite, and this test suite is using a different version of integer set. Right, so I have this modularity where I define the interface, the abstraction, for an integer set, and now I'm using it within the test with a specific version, which is hopefully going to be fast. So if I run this test suite now, bam. Just runs lightning quick. So it's 100,000 lines, 100,000 items that I'm adding and removing from this set of integers. But it runs really fast. And it really depends on my internal representation. Right, so what I did is I swapped out my internal representation by defining a new kind of integer set. You guys have any questions? Did everybody follow? Might have been a little fast.
Interfaces to hash set, integer set.
How I did what? Oh, the basic format. So you mean the refactoring stuff. So if I want to ever, so I have an implementation, right? But this implementation is very concrete. So if I want to extract an interface, this is a refactoring operation. So I right click on it, and I go to refactor. And here you can extract an interface. So what this does essentially is it pulls out the methods that I have declared, just the public ones, and then it pulls out the comments along with them. So if I do this, I can create a new integer set 2. And here I get to specify which methods I want to include. So I selected all of them. So I'll have a second interface, integer set 2. Right? And that's all it does. It just creates this thing.
For the implementation of hash set, integer set, why are there overrides and overrides above the methods?
Yeah, so override is this annotation, right? Remember the at symbol is an annotation, and at test, at before, we saw it in the JUnit framework. So at override basically tells me that there is this implementation, so there's this integer set interface, which has these methods. What I'm doing here is I'm essentially redeclaring them, right? I'm declaring them again. In order for me to redeclare or give you another declaration for a method along with its implementation, I have to use add override. You'll see this later in a different context. It'll make a little bit more sense. But think of it this way. If I have an interface, integer set, if I'm implementing one of the methods, I have to use add override.
So what would happen if you didn't have the add override?
So if I did not, I'll get an error. Should get an error. Ah, I did not get an error. typically an override is a good practice for including, but it's not always necessary. I think in this case it might not be necessary. But the idea with that override is you'll see it in the inheritance context, which we'll cover next, which is going to be talking about essentially declaring new versions of methods. In this case, you don't need it, I think, because the integer set interface doesn't have implementations of these methods. So it really is the first implementation.
Can you explain just like what that internal representation word, why does that have to be there? Is that?
So it's a field, right? I just gave it this funky name, internal representation.
That's his name.
Yeah, so it's in blue, right? So blue things are things that I name. So I could change it to something else. I could just call it my set, for example. Yeah, so you don't have to choose this name, but the idea was that abstractly, my set is an internal representation of a set.
Why is the hash set actually faster than linked list?
Well, because it's a different data structure. So you'll have to take a class on data structures to understand why that is. So I won't go into that. But really it's because internally it represents or stores data differently. Right? Even though it has the same operations, right? Like here I have the hash set version and the linked list version. And if I looked at the set of methods that I'm actually invoking on the list and the set of methods I'm invoking on the set, they're kind of the same. I can remove stuff, I can check if it contains stuff, right? But the way it maintains memory is different, and so the efficiency of these operations is different. Questions? So what if I add a new method to my linked list integer set? Would that be legal? So my linked list integer set implements this interface. Now we know that if I change the interface, if I added a method to the interface, then anything that implements it has to implement that method, right? I showed you that error. But what if I add a new method to the class that implements it?
You can add it.
I could add it?
Yeah. Because you implement the interface and you have to use methods from that, but it doesn't specify that you can't add any methods. It just specifies what methods you absolutely have to add.
Okay, so let's check that.
That's
So I can declare a method food. Well, it's int. I made a void, and I have to return anything. So now my project compiles, and I have a new method as part of my implementation of an integer set. So that's fine, right? I can declare new things in my linked list integer set. But the problem is that if I were to actually use them within the test, I won't be able to. So here this set is an integer set. And if I do set.food, it's actually, well, even if I changed it, linked list integer set. This food is not going to compile. So why is this food not compiling? Why can't I do set.food? So I did set equals new linked list integer set. It looks like I created an object of this class. This class contains a public method called food. So I'm invoking this method here. What's wrong? Why isn't it working? So why wouldn't it work if I had this code? Ah, of course I changed it. So if I had a hash set integer set. So here's my hash set integer set. I'm calling foo on it. So this doesn't work because there's no foo in my hash set. Hash set integer set has no method foo, right? And my implementation is of a integer set interface. My interface also doesn't have foo. So of course this guy says it's undefined. But now if I have my linked list integer set, this guy does have food. Why can't I do this? Any ideas?
Is it because our interface don't have it?
Is it because my interface doesn't have it? It's a good question. So let's check. So if I add it to the interface, public void food, then it's no longer a problem, right? It went away. Why did it go away? It's just very magical, right? Okay, so here's the reason why. So this, if I remove it from here, from this interface, the reason this doesn't work is because set is not of this type. It points to an object that has this type. But what is the type of set?
Integer set?
It's an integer set, right? It's defined above in this field. So the type of set is, you can find it out at the declaration. And the declaration of this field is above. And it says that set is of type integer set. Integer set is an interface. Right? So the only thing that set knows about are the methods that are defined within the interface. So even though I extended linked list integer set with this foo method, I can't actually invoke it on set because set is an integer set. Right? It's really kind of weird. So here's another weirdness example for you. So I can have set A and I can have set. Let's say I have another integer set, set A. I can actually do the following. I can set set to be set A. Right? So I create an object called integer hash set integer set, and create another object called linked list integer set. And then I swap them here. Okay, why does that work? Here's the reason. So I have this interface which is integer set. Integer set I face. So I have set. And I have set A. And they're both of this type. Right? They're both integer set. When I create objects, I'm creating them from classes. Right? So kind of like this class here, I have the linked list. Integer set. And I have the hash set, integer set. So these are classes, right? And then when I'm creating things, I'm creating objects. So I have some object that's going to be my linked list version, and I'll have a different object. It's going to be my hash set version. And that's really what this new code is, right? So when I say new hash set integer set, I just created an instance of the hash set integer set class. So I create a new object, and then when I said new linked list integer set here with a new keyword, I created a new object. And these guys live in memory. Those are dynamic objects, right? You can only see them when you're actually running the program. So my set refers to the linked list. So it refers to this guy. That's what it points to. My set A refers to this object. But they see a very constrained version of that object because their type is integer set. So in some sense, both of these guys share some kind of like a filter. And this filter is the interface. And this filter constrains what they can see and what they cannot see. But because both of these objects implement the same interface, I can actually have set point to this other guy. So I can change what it points to at runtime. And that's what I'm doing here. So when I created these two objects, these were the arrows. So they just went across. And then when I said set equals set A, I just changed what set points to be the same thing that set A points to. And the reason I can do that is because they implement the same interface. Because I can talk about them as these abstract integer set instances. So I'm not talking about them as implementations. Because if I did that, so let me give you another example. Let's say I have the H set equals new hash set. I call this guy hash set H set. And then I also had the linked list integer set, L set. And I created a new instance of that as well. So right now they're very similar, right? So this H set, well, this H set is kind of like set A. And this L set is kind of like set. Very similar because they're pointing to the same kinds of objects, right? But if below I said H set equals L set, it's not going to compile. And the problem is that it's a type mismatch, right? Because these two types are different. And I can't convert between these two types. Java won't let me. So this example above, these set A and set, the reason I can run the statement is because they have the same type. Okay? Even though the objects underneath might be different. Now, it doesn't work here because the types of H set and L set are actually different. And so Java's going to complain. You guys see that? So another way of saying that is that if I have an H set and an L set, and now they're pointing to these two objects, that I just created, I can try to make H set point to this guy, but it's going to fail. And the reason it's going to fail is because now I don't have this interface shielding. Right? These are actually raw objects, and they belong to different types. It's like saying integer I and string s, and then saying I equals s. How do I convert between an integer and a string? There's no way. So that's essentially the example here, right? We could have just as easily demonstrated by saying string s equals new string, and then I could have said integer I equals new integer. I. Then I've said I equals s. And that would be exactly the same error. Except that here, the types that I'm using are the types we introduced with classes. So they're these custom data types that we added to the language. And here I'm actually using built-in classes that Java has. Questions? What's confusing? Are the interfaces confusing?
How would you build an interface so that I is equal to S would work?
So that I is equal to s. Well, first of all, they'll have to have the same type. Right, so I might have something like maybe string int. Okay. And then I'll have to create, they'll have to look something like this, right? Where actually string int is, right? Then I'll have to define what the string int actually represents. Right, so it could internally maintain both strings and both integers. And then I'll have to make sure that string implements this integer, and my integer implements this. Right, and then I'll be able to make this assignment true. So right now this assignment works, because Java says, well, they have the same type, I don't know what it is. Right, so I could say, all right, create a class of string int, or create an interface. But then I'll actually have to modify these implementations, which are within the Java library, and that's hard. So if you were to actually do it, you'd define your own versions of a string and your own version of an integer. But yeah, it's possible.
Would you generally create your interface first, or would you, because the way you did it, you created an interface from an implementation?
Yeah, so that's a great question. So the question is, do I create my interface first, or do I extract my interface from my implementation? What do you think?
It seems like it would make more sense to make the interface first.
Yeah, so that does usually make a lot of sense. And it makes sense when you know the operations that you're going to support, and you know that your interface will be reused. So remember, like here, I created this integer, hash set integer set. If I didn't have this hash set integer set, like if I removed it from the program, then what role does my interface play? My interface is just one more layer, right? It's like an abstraction, but it's not a necessary abstraction. I'm not actually using it, right? So it allows me to create new types underneath that implement the interface. But if I have only one type that implements it, I don't actually need that interface, right? So usually you implement interfaces when you know that there's going to be multiple data types, that will implement it. But sometimes you don't know ahead of time, right? So maybe you start off by implementing things, and then you extract the interface and put it in later. So software kind of evolves over time. Other questions? Okay, so we'll get to practice this a whole lot, I think in the next class. Data types as well as interfaces. So come with questions.